Hey, welcome to Weld.com, home of TIG time. Hi, I'm Mr. TIG, and today we're at Leno's garage, and typically we weld up car parts or engine parts or things like that. But today we've got a very unique project, and it's a tough project. Jay brought to me this pedestal, and it looks like a normal pedestal. It's made of cast iron. Well, that in itself is not good because cast iron is almost impossible to weld. Now, the particulars of this is that it is over 100 years old, so it was turn of the century, and this is a base for a hot water heater. And I'm going to get him to come over after I finish welding on it and give me a little more description. But here's what's critical. It's very difficult to weld cast iron, first of all, because you don't know how clean it is. There's a lot of trash elements in it. It's high in carbon, and the material, when you weld it, will weld dirty, but when it solidifies, it shrinks, and this material only allows you about 2 to 4% elongation. So I have a filler material here that a company sent in, and I did this once before. There was a previous show that we did. This company is called Easy Weld TIG wire, and so the guy called and said, you can weld cast iron and you don't have to preheat it like, you know, in the past we used to preheat everything, bring it up to a couple hundred degrees, wrap it in a blanket when we finish, let it cool down. This material is a cold weld material, and meaning that all I do is I'm going to prep this. I'm not going to prep it very deep. I'll put a little channel or a little groove in it, and then I'll go ahead and weld it cold. I'll do no preheating whatsoever. Yeah, so let's see how it does. And you know, the risk of any of these projects, you send me wire to use, I'll use it, and we'll see if it works good, bad, or indifferent. And unfortunately, what happens a lot of times in cast iron, you don't know until you weld how dirty it is. So let me get my gear on. I'm gonna pre-prep this, and I'll get back with you shortly. Okay, now I'm going to take an air grinder and put a little channel in here just to get down through the surface contamination. I'm only going to make the channel less than 50% because, again, when the filler resolidifies, I don't have a lot of elongation available. So let me put the channel in, get it prepped, and then we'll show you the actual welding process. Okay, now I've got this 100-year-old cast iron. I've got a little V-prep in it. You can see it's actually a little U-groove. So I used my carbide, and I maybe made the groove 25% of the wall thickness. I'm going to weld this DC using this easy welding wire that was provided to me that said it'll weld cast iron beautifully. So we'll see. 100-year-old cast iron, I just don't know what to expect. So I've got a 332 tungsten, you know, it's pointed. My argon is between 15 and 20 CFH. You can see my stick out is only about 1/4 of an inch, and that's normal. That's just a good baseline start. I'm probably going to weld this somewhere in the neighborhood of 100 to 125 amps. So let me flip the hood and share with you what I've got right here. Okay, sometimes you drill a complete through hole where we see the end of the crack, but in this case I just took a ball router and created a nice little semicircular hole, and a lot of times that'll do the job. This cast, I mean, it just is dirty. There's no other way around it. Got to be patient with it. This filler that I'm using is it's very surprising of how clean it welds. It kind of takes the dirty, nasty cast iron, and I don't know, whatever's in it, it's mixing very well. And you know, I'm keeping the heat to a minimum. You know, having a little channel in here has worked out real well. So I've got a real slow travel speed. I'm adding filler. I'm just dabbing, the normal dabbing technique. I'm not trying to add anything special. I'm not trying to create any more dabs than normal. I'm just kind of watching the puddle, and I might not be able to make the full run without having to reposition myself. So whenever you terminate your weld, which I'm getting ready to terminate and reposition myself, never terminate it with a low weld. Always kind of back up. I'm backing up right now, and I'll terminate on the side of the weld. So I reinitiated the arc, and I backed up into the weld where I had some filler material, and I'm just traveling along at a very slow pace. I can hear things popping and cracking, and very common with this material. You just don't know where it's going to crack or break the next. So it'll eventually, when it cools off, it'll find the weak link, that's for sure. Okay, so I'm going to terminate my weld right here, this flange, and it's, you know, the whole part is warming up. I'm going to go ahead and resume this weld. This is all on the back side, so we'll weld this about the same heat at 125 amps. Again, adding filler material. And you know, no matter what you do, no matter how good you prep it, no matter how good your filler is, you're subjective to the cast itself. And some casts are weldable, some aren't. Some may crack a little more. Now I'm going to go ahead and turn this over while it's hot. I'm going to turn it over and take a look at the back side. Now this is the back side of the weld, and it certainly is running dirtier. I mean, I can see a lot of crud and corruption in here. It doesn't want to weld quite the same way. You know, so we'll dredge through this. I'm going to back up a little bit because I had an area that just absolutely did not want to take. Okay, so I backed up and added filler, and this time it did take. Again, a lot of crud, a lot of corruption in here, a lot of floaties. So, just got to be kind of patient with it. I'll tell you what I'm going to do is, I think I'm going to back off in my weld temporarily. I'm going to do a little re-cleaning process. Okay, now this thing, I could hear it crack. Again, that's not uncommon. So I want to make sure that I get some nice alloy in here. That should help it out quite a bit. Okay, I got to reposition. Okay, now while everything is hot, I'm going to back up because I got a crack here that's still about 1 inch long, and I'm going to rerun it. I'm going to add some more filler to it. Okay, so it actually re-welded very nicely. And I'm going to back step it again. I'm going to go to the very beginning where I had kind of a stop drill hole here. And that's just in case it's trying to spear out a different direction.
Oh, that looks great.
And Jay, what I did is I put a little groove in there to get into some good material,
Right.
and use this special alloy rod, and it it took pretty good. But here's my question: how old is this?
This is about 1900. This is a stand for a water heater that came out of the actor Danny Kaye. You know, see, people our age know who he is. You talk to anybody under 40, they go, what?
My parents told me about Danny Kaye.
Yeah, well, there you go. Well, he was a huge star.
Yeah.
And this gentleman called me and said, I got this water heater. I know you like steam and stuff, so would you like it? And I said, well, all right, let me go take a look at it, you know. And so it's such a cool looking piece. I mean, it's very ornate, a very early 1900s, and it's a very early version of a tankless water heater. You know, we always think this stuff is brand new.
Yes.
But whatever we've had, we've always had. It's just metallurgy or technology or whatever. But I'll show you the thing that sits on. I think you'll think it's pretty cool, and it's worth saving. I guess we still have to fill this, right?
Yes, we do.
Okay, but come on, I'll show you the actual water heater.
Good.
Here's the actual, here, we'll roll it in. Here's the actual water heater right here. Obviously it's on a dolly now because it's standard underneath. But as you can see, these doors open, and inside the doors are some copper coils.
Okay.
And you heat the coils, and the water hit the coil and instantly it turned hot, so it was continuous, you know, so you wouldn't run out of water. So this was, a rich person would have had this back in the day. It's pretty fancy.
So hot water on demand.
Yeah, that's what it was. That's basically what it was. So it's kind of cool. It's made by Rudd. And it's just, I mean, the little handles and the delicateness of it, you know, all the beautiful scroll work and stuff up here. It just seemed too nice to scrap.
Yeah.
So we're going to clean it up, and thanks to your welding, another piece of history has been saved.
Well, good.
Thanks,
Good.
guys.
Well, hey, thanks for bringing us these projects, because otherwise, how do you run into
Yeah, it's
100?
like Tom Sawyer painting the fence. We got lots of projects for you guys. Oh, yeah.
All right, well, we'll be around. And
Thanks, guys. Appreciate it.
That's what we do.
Thanks.
Thank you. Thanks for watching TIG Time. I'm Mr. TIG.
I'm Mr. Time. First of all, you got to have gray hair to do this properly. Isn't that correct?
That is correct.
These young punks watching this video, I defy any of them to weld as good as this guy. You have to put the challenge up.
Well, I got to tell you, I have a cheater lens in there.
You got the cheater lens. And look, and you got the PlayStation helmet. Yeah.
Absolutely.
How long has it been since he's been with a girl that looked like that? Huh? I ask you that. But when you're a welder, those are the kind of women you meet. That's right.